Illustrative Math, Algebra 2, Unit 7, Lesson 7 is called Areas Under a Normal Curve. Goals today, I can use the mean and standard deviation of a normally distributed data set to estimate intervals when given a proportion, and I can use the mean and standard deviation of a normally distributed data set to estimate proportions. So our warm-up images show a normal curve with a mean of 40 and a standard deviation of 2. The area under the curve to the left of 39 is 0.3085. The area under the curve to the left of 43 is 0.9332. Okay, a couple things to remember here. If the mean is 40, that's right there in the middle of your curve. Okay, so these are the same curve, just different areas. Find the area under the curve to the right of 39. So this is 39. So this would be 1 minus 0.3085. So if I click on that, so it'd be 1 minus 0.3085, and I get the 0.6915. Find the area under the curve between 39 and 43. So 39 to 43. So if I look here at this curve, I just move that right there. It'd be this area right there. So I could take this area, 0.9332, and subtract that area right there, the 0.3085, and that should do it for me. Okay, so right there, the 0.9332 minus 0.3085, and that gives me 0.6247. Okay, so that would be that area right here, this region right here. Okay. Number 3, find the area under the curve to the left of 40. Well, that's easy. That's the mean right here. So it's halfway on each side. It's symmetrical. Anybody should be able to get that. It's 0.5. And the distribution is symmetric, so half the area to the left would be 40. And between 39 and 40, so that's going to be 0.5 minus this value right here, 0.3085. And when I go ahead and do that, I get 0.1915. Okay, subtract them. There you go. All right, so the lifespan of light bulbs is approximately normally distributed. Some statistics about lifespans of 2 different types of bulbs are listed. So we got LED and we got incandescent. They give us the mean for both of them, and then they give us the standard deviation. To estimate the proportion of bulbs that burn out in a certain time interval, use technology to find the area under the normal curve and above the appropriate interval. Okay, so I'm going to use Desmos to find my info. If you have a TI-84 graphing calculator, or if you're not allowed to use Desmos in your class, just follow along with me so you get the idea, and then you have to figure out how to do it on your 84 with watching another video or talking to your teacher. But as far as Desmos goes, it's real easy. It's nice and visually sound. So I'm going to use that for this video. All right. And what I did too is, if you're following along and if you have a textbook and you're following along, I split these up because they flip back and forth from LED to incandescent. So I'm just going to stick with the LED ones first, and then I'll do all those questions, and then I'm going to go to the incandescent next. Okay. So it's real easy to do statistics on Desmos. All I'm going to type in here is normal, DIST. Okay. And then I put the mean first. So 2300, I put a comma, and then I put the standard deviation. Okay. Now it's going to graph it here, but it's going to be kind of not centered. So if I hit this little plus sign here, that'll zoom fit, which is awesome. There it is. And I really don't need these grid lines, so I'm going to turn my grid off. And then it says find cumulative probability. Okay, so I hit that button, and it defaults to go from negative infinity to infinity. So it'll highlight the whole thing underneath there. Okay, so when I look here, it says estimate the population, the proportion of LED bulbs that are expected to burn out before getting within one standard deviation of the mean. So one standard deviation of the mean. So your mean is 2,300 days. So if I want to go within one, so that'd be one less, I minus the standard deviation. That's how they get this 20,070. Okay. So that's how that number comes about. So when I look here, if I type in my min, negative infinity, or I guess I could type in 0 because you're not going to have negative bulbs, and I want to go up to 2070, it'll highlight it right there. So that's within one standard deviation. Okay, so if I type this in x equals 2070, and I type another one in x equals 2300, that right there, this region is one standard deviation to the left of there. Okay, if I want to go another standard deviation, I would subtract 230 from there, and I would go even, I would get another line over here, but not really necessary. But anyways, the answer here to this is 0.1587. All right, so then I'm going to go down to the third question. Estimate the proportion of LED bulbs that are expected to burn out after getting more than one standard deviation greater than the mean. Okay, so now we're basically going to go one standard deviation up. So we're basically saying, I don't really need this, I'll turn that off. We're basically going to be from 0 to 2,530 days. So it's going to be this region. So this is one standard deviation above the mean right there. So anyways, my answer is, hold on. Oh, it says more than one standard deviation. So actually I have to change that here. That's going to be my min, 2530 up to infinity. You can just type infinity. So it's actually going to be that region right there. Okay. So that's going to be the same number, 0.1587, because it's really like kind of symmetrical, what I had before. All right. And then we're going to go on to the next question here. So number 5. Estimate the proportion of LED bulbs that are expected to burn out in an interval between one standard deviation less than the mean and one standard deviation greater. If they didn't give you this info, you would just take the 2300 for your mean, and this way we would add 230 to get to the 2530, and this way we would minus 230, and that would get me to the 2070. Okay, so that's how we would go each way. So I'm just going to go over here. I'm going to change my numbers, and I'm going to plug it in. So it's 2070 to 2530, and it's 0.6827. So then I'm going to go on to the next question. So number 7. Estimate the proportion of LED bulbs that are expected to burn out in the interval between 2 standard deviations less than the mean and 2 standard deviations greater than the mean. So again, we would take those two values that we just had up here, and we'd subtract 230 again, add 230 again to get these numbers here. So I'm just going to change them in here, and it'll give me a nice picture there. It'll shade the region that we want, and that's 1840. And then this is 2760. So that's 2 standard deviations. So, think of this as that's my mean. There's 1 standard deviation. There's 2. I'm a little off on my size there. So this is going to be the same right there. So these should be equal in width. So 1 standard deviation each way, 1 standard deviation each way gives you the area here is 0.95, 0.9545. And then the last question here for the LED bulbs, estimate the proportion, of LED bulbs that are expected to burn out in the interval between 1900 and 2100 days. So this is not necessarily a standard deviation question, but because those numbers are not exact breaking points of standard deviation from the mean. So I'm just going to type them in, and the answer would be 0.1513. Okay. All right. So now I'm going to go back up to the top, and I'm going to graph the LED bulbs. If I can get this thing to work. All right, so hang on a second here. All right, so sorry about that. Somebody came in as I was recording that. So here, let me clear all the ink here so we can just answer the questions that we have here. So, all right, let's get rid of this graph and let's type in our new one. So normal dist, and it's 100 days, comma, 10 days for my standard deviation. I'm going to zoom fit, and I'm going to find my cumulative probabilities. Okay. Question 2. All right. Within 1 standard deviation of the mean, so before 90 days. So my minimum is 0 or negative infinity up to 90, and we get 0.1587. And we move down to number 4. So after 110 days, so we're going to go from 110 up to infinity. So we get really the same value for 1 through 4, 0.1587. And we scroll down to number 6. 1 standard deviation less and 1 standard deviation greater. So you just add 10 to 100 and subtract 10 from 100. So that's going to be from 90 to 110. There's your area right there. And it's 0.6823. I'm sorry, 0.6827. Whoops. Caught it. All right, we go down to the next question. Is all the way down to number 9, I think. Estimate the proportion of incandescent bulbs that are expected to burn out in the interval between 107 and 110. So right there, that's not a standard deviation number. Or sorry, 107 and 118. Sorry about that. So that would be this area, and that's 0.2060. Okay. All right. Another situation where we're going to use the graph. The wait times at a popular restaurant are approximately normally distributed. The mean wait time is 24.3 minutes with a standard deviation of 3.2. Use technology to estimate the wait times for the described group of diners. So I'm going to type this in again. I'm sorry, I was typing that wrong. Type in normal and then DIST. Type your mean, which I think was 25.3. Let me go up so I can read it. Nope, 24.3. And then put a comma and then your standard deviation. And then hit this to zoom fit. And then click that to find the cumulative probability. I'm going to turn my grid lines off. Don't need them. All right. So 10%. So describe the number of minutes diners have to wait if their wait times are in the longest 10%. So we're really looking for 10% of the area over here. So I'm going to say, I'm not going to change the infinity, but I'm going to just play around with this number. 30, not enough. 28, too much because that's 12%. So maybe like 28.9, not enough. 29, still not enough. 29.5. I'm sorry, 28.9 was, I need it to be bigger. So it's actually got to be 28.5. How about that? A little bit smaller. 28.4. That's pretty good. All right. And I did these earlier, so I wrote the numbers down so we can check them. Okay, good. 28.4. All right. So then we go down to number 2. Describe number of minutes diners have to wait if their wait times are in the shortest 15% of wait time. So we want over here where it's 15% of the graph. So we're going to go, you can do negative infinity or you can do 0 in this case. So I don't know, I'm going to just start with 18. Not even close. So let's try 20. Not big enough. 21. That's pretty good. Maybe a little less, 20.8. No, 20.9. 20.95. A little bit more, 20.98. That's pretty close. And that's what I said there, 20.98. So I'm just going to trial and error until I get it. All right, 3. Draw an example. Keep clicking that, sorry. All right, to find the wait times for the middle 50% of wait times for diners, draw an example of a normal distribution in shade approximately the middle 50% of the area under the curve. Okay, so let's do this. Let's get rid of that. I already did this. So here is an approximate middle 50%, okay? Right about there. What percentage of the total area is unshaded to the left of the region? And what value marks the line between the unshaded and shaded? Okay, so as I look here, this would obviously be 25% if this is 50% because it's symmetrical, so it'd be 25 over here. What value? Looks like 22 point something. All right, I don't remember what exactly I found it to be, but it was 22.1 approximately. That was for B, I guess. What percentage of the total area is unshaded to the right? I already answered that. That's 25. that looks like it's about 26 point something. Now, these values here should be equidistant from the mean. I would have to go and take a look at it. 26 point, let's do this, 24.3 minus 22.1 gives me 2.2. So if I added 2.2 to 24.3, I get 26.5. Okay. That way these are equidistant. Okay. I don't know why I put percent here. That shouldn't have been a percent. All right. The shaded region is between which two values? So obviously right there it's 22.1 to 26.5. All right, the diners who have wait times in the middle 70% are between which two values? And you could trial and error this on your graphing utility. For the sake of time, I just did it, and that's what you would get. Okay, so just make sure these values are equidistant from your mean. Okay, so if I did 23, what does I mean 23, 24.3, I should get the same value 24.3 minus this, and then this minus 24.3 should get the same value. All right, so last thing here, a couple questions tied all together for our lesson synthesis. In what ways can you investigate data by using the normal distribution as a model? A normal curve can allow you to estimate the proportion of values expected in certain intervals. Why are we finding the area under the curve? Area under the curve tells you I put the twice, the proportion of values in a certain interval. What proportion of values would you expect to be within one standard deviation of the mean? So the answer is around 68%. Now, what you're going to learn and you're going to find, and this book doesn't tell you this, so I'm going to kind of cheat and ruin the surprise, is standard distribution will always look like this. 34.1% are within one standard deviation of the mean on either side. So 34% to the left, 34 to the right. So it's really 68.2%. I just rounded it to 68. All right, so what proportion of values would you expect to be more than two standard deviations? So it really would be here, it'd be like adding these percents within two standard deviations. It's this whole area from here to there, okay, that whole area. Okay, so add all those up, and it's going to be about 5. Oh, more than 2. So I guess it'd be all of this. Really, it'd be 1 minus all of these if they were in decimal form, or 100 minus all of those if they're in percentage form. Or I guess conversely, you could just add all these up here. Now I know these aren't going to add to 5. It's going to be more like 4.4. And again, this is just an approximate, so that's why. So last thing, how does technology assist you in interpreting proportions using a normal curve? Technology allows us to find area under the curve for any value. Once I use standard deviation and the mean to create the normal curve, I can estimate the proportion for any interval. All right, so back to our goals. I can use the mean and standard deviation of a normally distributed data set to estimate intervals when given a proportion. And I can use the mean and standard deviation of a normally distributed data set to estimate proportions. All right, last thing. It's estimated that the weight of a population of brown bears is approximately normally distributed with a mean of 600 pounds and a standard deviation of 120 pounds. Approximately what proportion of bears in the population weigh less than 720 pounds? So 720 is one standard deviation to the right of the mean. So I already went ahead and graphed this and just attached a picture. So my mean is right here at 600. So, this is one standard deviation to the right. So I put my min as negative infinity, or I guess you could do 0 here. And then my max is 720. And right there we get our answer is 84, it says 0.8413. It says what proportion. It doesn't say percent. Okay, and again, back to what we were just talking about on the synthesis, it's going to be really from here, this line. Let me draw a straight line here. It's going to be from here on over here. So if I added up all these numbers here, 34.1, 34.1, 13.6, 2.1, 0.1, it would be really close to what we got here. But again, these are rounded. This is much more accurate using technology. So hope you enjoyed this video. Thanks for watching, and we'll see you next time.